Hi, welcome to lesson number 2, module 6 of the Apache Spark and Scala course. So in this particular lesson, we will be looking at why somebody should prefer Spark streaming over other traditional streaming solutions. So before we proceed, let's quickly recap the last lesson. So in the last lesson, we introduced the concept of Spark streaming. We looked at the features of the same and also had some of the industry use cases of Spark streaming. And then we understood the overall system design and some of the challenges associated with Spark streaming. So in this particular lesson, we will be understanding what exactly is real-time analysis and what is the difference between batch and real-time. We will also have a look at the Apache Storm framework, which is built for streaming, and we will compare Storm and Hadoop with Spark streaming and understand what are the advantages of Spark streaming. So what exactly is real-time analytics? Real-time analytics is a term used to identify analysis that is happening on the data which is as soon as entering into the system. So an example, like I said, will be analyzing tweets, which is social media data. So let's say that you want to know the most popular hashtags in Twitter. Now Twitter is a microblogging site and people tweet using something called hashtag. So what if I would like to know the most popular Twitter hashtag in the last 3 minutes? Now this is a classic example of real-time processing. This means I have to pull in all the data which has happened in the last 3 minutes in Twitter, then search through the data for all the hashtags, group them, count them, and take the top 3 hashtags. So the point in here is that I am reading the data and analyzing the data as soon as the data comes into the system. And this is exactly real-time analytics. Now, this will allow you to collect over terabytes of data in case you are using a cluster. And the data can be consumed either from a single stream or you can have more than one stream as well. And sometimes you might want to combine the historical data along with the real-time data. So probably you already have the most number of tweets that has happened over the last 6 months. So that is your historical data. So you already have a huge amount of data which comprises of all the tweets that has happened over the last 6 months. And then probably you are streaming the Twitter data live and identifying certain hashtags for the current 3 minutes. Then you might want to compare this with all the data that was collected over last 6 months. So it is very common that you might want to process live streaming data along with historical data. And also the streaming should also be able to stream the results to the downstream systems such as NoSQL databases. Now let's quickly compare the batch and stream or real-time processing. In batch processing, the queries are done on all or most of the data, and the data size is very huge, and the time taken to process the data might be from minutes to hours to days, depending on the size of the data, and the analysis becomes complex. But when you look at streaming data, the queries will be happening on the data that you have collected over a window of time. Now we will see what is this window. Basically, rather than analyzing the whole data, you will be analyzing the data on a batch of data. And you can have individual record or micro batch of few records. And the advantage here is that the performance or the time taken for analysis or running your queries will be in microseconds or milliseconds. And the analytics is very simple with a response function with rolling metrics. Now let's see stream processing using MapReduce. Now what if we did not had Apache Spark, and what if we were supposed to do the streaming data analysis using MapReduce? Now using MapReduce for something such as streaming data processing or iterative algorithms is very complex and tedious. Now we know that MapReduce is designed for batch processing, and during a typical MapReduce job, there is intermediate data write and read to the hard disk, which put huge latencies in processing. And streaming requires multiple transformations, which means if I have to design my streaming idea using MapReduce, I might have to do that using more than one MapReduce job. So when I'm having, let's say, 3 to 5 MapReduce jobs, which are clubbed as a chain of MapReduce jobs, running them in one shot becomes too tedious and time consuming. Now, what are some of the limitations of streaming on top of Hadoop? So traditionally, people were trying to achieve streaming on Hadoop before the invention of Spark. Now we know that MapReduce is not the solution, and the solution is your Apache Storm. Apache Storm is a framework which is used to efficiently work on streaming data. But the drawback of Storm is that Storm has its own API and the learning curve is much higher. That means for a new learner, they have to learn the entire Storm API from scratch, and then they have to learn how to implement it on top of Hadoop. Now again, Storm is running on top of Hadoop. That means obviously the data is getting stored on HDFS. And there is no way you can club Storm with MapReduce. So you cannot have streaming and batch jobs together. Maintaining 2 runtimes, one for MapReduce and one for Storm, is too tough. On the other hand, Spark streaming will allow you to combine batch and streaming workloads. This is not possible with Storm because Storm has its own API and it concentrates only on streaming. And if you want batch, then you have to use MapReduce. MapReduce cannot be combined with Storm. With that in mind, let's have a quick look at Apache Storm. Apache Storm is also stream processing engine, which is used for streaming application. Now, Storm is designed to do real-time processing, and this works on top of the Hadoop distributed file system. It has its own APIs. That means Apache Storm doesn't depend on MapReduce. And Storm was originally created in Twitter, and later it was contributed to Apache as an open source project. And Storm is created using the Clojure language. So that brings us the question, what about the comparison between Apache Spark and Apache Storm? Now, if you look at Spark, it supports micro batching, and Storm supports event stream processing. So there is a difference in this. Spark can run batch jobs as micro batches, but Storm is always doing event stream processing. And Spark is by default fault tolerant. You get exactly once delivery. But in Storm, you get at least once, at most once, or exactly once delivery. And Spark is coarse grain transformation, whereas Storm is fine grain transformation. What does this mean? This means coarse grain transformation means you are applying your program on a bunch of data as a whole. Fine grain transformation means you can individually apply your logic even on individual cells or lines of data. And Spark Streaming provides common platform for both batch and stream, where in Storm it is not able to do this. And Spark is written in SCADA and Storm is implemented in Clojure. So one of the key reasons why people love Spark is that it is a unified platform. Now look at Storm. Even though Storm is really great tool, if somebody has to learn Storm, then they have to learn the API, then they have to learn the integration with Hadoop, so on and so forth. But anybody who is having a basic Spark knowledge can start implementing streaming using Spark Streaming API within a day's time. Because Spark Streaming API uses the same Spark core and the same Scala language. You are basically using the same programming concepts, basic transformations. You are only getting a layer of abstraction called Spark Streaming on the original data. So the key reason why Spark is being loved is because it has a unified platform. So to wrap up, in this particular lesson, we have learned the concept of real-time analytics, and we compared real-time and batch jobs. We compared Apache Storm with Spark Streaming and understood the advantages of Spark Streaming. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.